Okay, so we are going to do some notes for 5.4. We do have some new vocabulary, lots of new vocabulary for 5.4. So we're going to get that vocabulary down, and then we're going to use the graph in the examples to help apply this vocabulary. All right, so one of the new vocabulary words that we're talking about is minimum. And we've talked about the word minimum before, but not in the context of a graph. Minimum is just the smallest amount that you can have, the lowest. And when we talk about this, the minimum of a function, we are talking about the lowest y value. Not x value. It's the lowest y value. The lowest output. So I'm going to put that like in parentheses here. The lowest output. Okay. A maximum would be the opposite. Again, we talk about this in terms of y values. So a maximum is the greatest y value, the most that there can be. And so again, we look at this in terms of the output of the function. What's the most I can have as my output answer? What's the highest output answer I could have? So we answer in terms of y. And then we talked about the movement of a function. And so we looked at how a function can increase, which again, we've talked about when we looked at slope. Increase means that my outputs are getting larger and larger and larger, right? I'm moving in an upwards direction. And so we state the x values. So our answer is given in x values, but we state the x values where the y values get larger. So I understand that this can get a little confusing. You are looking at the part of the graph where the y values get bigger, but you're answering in terms of x. For example, when I look at this graph over here, starting at the origin, my y values are getting bigger as I move left to right, but the answer I would give for increase would have to do with the x values where that graph is moving upwards, okay? The next word that we talked about was decrease. Again, we've talked about decreasing when we talked about slope. My graph is moving downwards when I look from left to right, but I'm answering in terms of x values. So we're going to state x values where the y values get smaller. Or again, where the graph is moving downwards. And the last one that we talked about was being constant. And being constant means that my y values are staying the same. And so we're going to, again, state the x values where the y values stay the same. Okay. And so in addition to this, we include domain and range. X and Y intercepts are things that we know, so those are fair game. So we do have a lot that is happening between review ideas and these new ideas. All right, so stick with me here. If I'm looking for a minimum, I'm looking for the lowest y value. And so again, I'm going to label this is my x-axis, this is my y-axis. I have this origin here, so my lowest y value looks like 0. It does not, I have a 0 over here. It does not look like I go below that x-axis, so I would say my lowest y value is 0. And my maximum is the highest y value. So unfortunately, my axis is not labeled. I'm going to assume we go by ones. This to me over here looks like my highest y value. So I got to count 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm just going to label that over here. And so we have y equals 9 is my highest y value. The y-intercept is where you cross the y-axis, and I'm crossing the y-axis or touching the y-axis here at 0, 0. And my x-intercept is where I touch the x-axis. Again, I am touching the x-axis at 0, 0, but I'm touching the x-axis again over here, so I should probably count that, right? This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And so I have an x-intercept at 13, 0 as well. I tossed some numbers on here. I started going by twos because when I go to write domain, range, increase, decrease, constant, I'm writing numbers in terms of x's mostly. The range I'll write in terms of y. So I wanted those labels there to help me. All right, domain is the stretch of all the x values that get used. That means I'm looking from left to right. From left to right, the smallest x value I use is 0. And the biggest x value I use is 13. And so I use every single number between 0 and 13 on my x-axis. My range is going to be from bottom to top. And so again, it looks like I have from 0 to 9. Notice that this goes with my minimum and maximum. So 0 is the smallest y value that gets used. So I'm using y for range. And 9 is the biggest y value that gets used. I use every y value between 0 and 9. Now, when I talk about intervals of increase, decrease, and constant, I am looking at where the function is moving upwards, downwards, or staying the same, but I'm going to answer in terms of x. So I'm increasing, I'm going to start my graph here at 0, and I'm increasing, I'm moving upwards. I'm still moving upwards. So I can just write one interval for this entire area of increase. I'm increasing from 0 until until an x value of 5. So my function's moving upward, and that's occurring between the x values of 0 and 5. Let's see, there's another spot on this graph where that happened. It's right here. And that happens between an x value of, it looks like 9 and 11. So between 9 and 11, between those x values, my graph is moving upwards. All right, how about decrease? So we'll do that in a different color. In decreasing, looks like I'm decreasing starting at this point right here, and I'm going to move downwards. So it looks like that's between 7 and 9. So between the x values of 7 and 9, my graph is moving downwards, and then I'm moving downwards again here. Between the x values of 11 and 13, my graph is moving downwards or decreasing. And so it looks like the last one I have is constant, and I have one section of being constant. That's this horizontal segment right here, and that happens between 5 and 7. So between the x values of 5 and 7, my function is staying the same. My y values do not change, okay? So again, we're looking for where the function is moving upwards, increasing, moving downwards, decreasing, or where the y values stay the same, constant, but I'm answering in terms of x. Okay, so your job is to do the 5.4 practice and ask me questions in class.